Hello everyone, welcome to today's session on surface areas and volumes. Okay, so in today's session we will look at the surface area and volume of a cone and a cylinder and a sphere. Okay, so three shapes we will cover. So let's look at the first shape, right? A cone. Okay, so what is a cone? And then we will also look at what is cylinder, and then we'll also look at what is sphere. Okay, so cone. A cone is kind of an you have seen like an ice cream cone, right? Like this one. See, an inverted ice cream cone, right? So basically, what it will have at the bottom, it is like a circular shape, which radius, let's say R, and a cone also has certain height. Let's say the height is H. And here, cone also have slant height. This is called slant height. That is L. See, because cone have like a slant shape, so that is slant height, that is L, and the actual height is H, and the radius is R. Okay, so that is cone. Now let's look at what is cylinder. So cylinder is anything. A cylinder is like a water pipe, right? So water pipe is in the form of like this, right? You understood? So the top and the bottom portion is circular, and then the other portion, like the length, is like this, right? For example, this the circular portion has a radius R, let's say, right? And from top to the bottom, let's say the height is H from here to here. You understood? So this is cylindrical shape. Now, what is a sphere? Like our ball. So which is in a circular shape, but it's a total solid, right? So this is a sphere. So let's say the radius of a sphere is, I cannot represent here the 3D shape of the sphere, but sphere, you know, right? It is like a cricket ball, right? Or tennis ball. So this is R. So now we have three shapes here: cone, cylinder, and sphere. So in a cone, two things you need to learn, right? So we will get surface area and volume. Okay, first let's see what is the surface area, right? So cone surface area is, so cone is in which form? What's the shape of this? This is like a triangular at the top, circular at the bottom, right? So there are two areas here. Okay, one is curved surface area, right? These shapes have curves, right? So it's a curved surface area that is called as CSA, okay, the short form, and also total surface area, total surface area, that we call it as TSA. Okay, the curved means this the the round shape, right? Whatever the surface area that we get on the ice cream cone, that is the curved surface area. Total surface area means at the bottom it is a circular shape. So the curved surface area plus the circular area at the bottom, if we add together, that is the total surface area. You understand, right? Total surface means wherever we have a surface for that object, the total area we need to calculate. So here the curved surface area, the CSA for this cone is pi r L. Okay, pi r into L. And what is TSA? TSA is this curved surface area plus the bottom is in the shape of a circular, right? So what is the area of a circle? Pi r square. You understood? So it is pi rl plus pi r square, or I can also write as pi r into L plus R or R plus L. Understood? If I take pi r common, it is L plus or R plus L. Both is same. So pi r into R plus L. You understood? So this is the CSA and TSA. Now here in a cylinder, what is CSA? The curved surface area is this portion, right? This portion. So what is the shape of this? It is still circular. So this is pi r. Sorry, the perimeter of this is 2 pi r as it is in circular shape. So 2 pi r into how much length it is? H, right? So 2 pi r h. The curved surface area of a cylinder is 2 pi r h. Now, what is total surface area? So here for total surface area, what it has, at the top it is a circle and at the bottom also it is a circle. So you need to add the circular area 2 times. In cone we added once, right? Pi r square. But here you need to add 2 times. So it is the curved surface area, which is 2 pi r h, plus the bottom circular area, which is pi r square, plus the top circular area, which is pi r square. So if I add this, 2 pi r h plus 2 pi r square, or if I take 2 pi r common, then this becomes r plus h, 2 pi r into r plus h. Understood? So here for cylinder, the curved surface area is 2 pi r h and the total surface area is 2 pi r into r plus h. Now sphere. So in case of sphere, right, it is total surface, right? There is no top or bottom for this. It is a completely uh, circular shape. So here for sphere, the curved surface area and total surface area both are same, and that is 4 pi r square. Okay. So for sphere, the curved surface area and total surface area both are same because there is no uh, top or bottom for a sphere. So it is 4 pi r square. So here what we learn, the surface area of each object, cone, cylinder and sphere. So the cone CSA, the curved surface area is pi rl. The total surface area is pi rl plus pi r square, or pi r into r plus l. In cylinder, the curved surface area is 2 pi r is the perimeter of the circle into h, because it has a height of h. That means if you add like 1 centimeter or 1 centimeter circles of h height, then that is your cylinder. So that's why 2 pi r into h. And the total surface area is that curved surface area 2 pi r h plus the bottom circular area pi r square and the top circular area pi r square. So 2 pi r h into 2 pi r square. So 2 pi r into r plus h. And for sphere, the curved surface area and total surface area both are same. That is 4 pi r square. Okay. Now let's move to the volumes, right? So same thing. This is the cone, right? This is cone of radius r, height h, and slant height L. That's the cone. Now cylinder. So cylinder is like a water pipe which has circular bottom and circular top. The radius is uniform, which is r, and this height is nothing but h. And this is also r. That's the cylinder. Now sphere. So sphere is like a ball which has a radius r. Now, so what is the volume of cone, right? So the volume means, for example, uh, we have a bucket. So bucket, if you fill with water, what we can say, it is 20-liter bucket or 30 liters bucket. So that's the volume, how much water that it can accommodate, that's a volume. So for a cylinder, the formula for the volume is 1 by 3 pi r square You understood? So the volume of a cone is 1 by 3 pi r square L. Okay. So basically it is the surface area, which is pi r L. Okay. The pi r L, pi r square. It's L or H. Let me quickly verify. Okay. Yeah, I'll confirm that in a minute. And also the volume of a cylinder is how much? So what is the area? This is a circular shape. That is pi r square into how much length it is h. So this is the volume pi r square h. Okay, so pi r square is the area into h is the length. So that's the volume pi r square h. And similarly for sphere, the volume is 4 by 3 pi r cube. Okay, so the surface area is 4 pi r square, and the for sphere, the volume is 4 by 3 pi r cube. Okay, we need to remember that. So the surface area is 4 pi r square and the volume is 4 by 3 pi r cube. And for cylinder, it's pi r square h. And uh, for cone, it is 1 by 3 pi r square h. Yeah, I had that doubt. So this is 1 by 3 pi r square h. Okay, the height we need to multiply. Okay, so the volume we learned the surface area, CSA, TSA, and now we learned the volumes. So these formulas you need to remember to solve the problems. Then we can get into the problems. Okay, so another thing here. So sometimes they'll give hemisphere. Hemisphere means half of it, right? So if this is total sphere, if it is divided into two, this is one hemisphere and this is one hemisphere, half of it. If it is half, then what the volume becomes? So the volume of the hemisphere become half of the sphere volume. That means 2 by 3 pi r cube. Similarly, for hemisphere in the previous the surface area, right? For hemisphere, the area becomes half of it. That means 2 pi r square. You understood, right? For hemisphere, it is half of the surface area, that is 4 pi r square, which is 2 pi r square. And for hemisphere volume, it is 2 by 3 pi r cube. Okay, let's quickly review the formulas. So for cone, CSA is pi r L and TSA is pi r L plus pi r square. And for cylinder, CSA is 2 pi r H and TSA is 2 pi r H plus 2 pi r square. And for sphere, CSA and TSA both are same, that is 4 pi r square. And if it is a hemisphere, then it is 2 pi r square. And the volume is 1 by 3 pi r square H for cone and pi r square H for cylinder. And for sphere, it is 4 by 3 pi r cube. If it is a hemisphere, it is half of it, which is 2 by 3 pi r cube. Okay, now let's move into problems. Okay, so this chapter in the entire 10th class mathematics, this chapter has the most complex problems. Okay, so bear with me, try to focus and understand. I'll go step by step how to solve and how to analyze the problem, get to into our standard shapes. For example, if you look at this, right, a medicine capsule like the tablets that we take, that is in this shape, right, is in a shape of cylinder with two hemispheres stuck to each of its ends. That means, so what basically they are saying is, if I cut it here, so this is one hemisphere, and if I cut it here, this is another hemisphere, and this is a cylinder. You understood? So this middle portion is a cylinder, and this side is a hemisphere, means half sphere, and the other side is also half sphere. And here the lengths are given. So what is the diameter, right? And the length of the entire capsule is 14 mm, and the diameter of the capsule is 5. So if the diameter is 5 means, so can I draw like this? If this is the hemisphere, right? So this diameter is 5 mm, right? This is 5 mm, and then we have a cylinder. So I'm just separating the shapes. Okay. So that way it will be easy for us to calculate whatever is asked. So I am converting this into three shapes. So this is 5 mm radius if the center is here. And this is, yeah, this we need to find. If this is 5, what is this length? And what is this length? This is radius, right? So should be 5 by 2. You agree? This is 5 by 2, right? This total is 5, right? From here to here, that is diameter, that is 5 mm. So if that is 5, this is the radius, right? In a hemisphere, in a hemisphere, this side up to the top is a radius, which is 2.5. And this is also 2.5. So if this is 2.5 and this is 2.5, then what will be this length? 14 minus 2.5 into 2. You agree? So here it is 2.5 mm and this is 2.5 mm. So if I subtract that, 14 minus 5, that is 9 mm. So basically, this cylindrical length is 9 mm and the diameter is still 5, even for the cylinder. So now this is, I divided into three shapes. That is two hemispheres at two ends and one cylinder. Now let's see the length of the entire capsule. Find its surface area. So we need to find the surface area. Surface area means this total area. This total area along with this thing we need to find. So here, very simple, we have two hemispheres. So we know the formula for the surface area of hemisphere plus we know the surface area for the cylinder. So here it is all curved surface area. Okay, because it's a joint shape. I have split that, but it was a joint shape. So for cylinder, we just need to consider the curved surface area. So here the total surface area. So the surface area equal to, right? So area of hemisphere plus CSA, right? Curved surface area of cylinder plus TSA or CSA, both are same for hemisphere. So you can write just area of hemisphere because I have two hemispheres, right? So what is the area of a hemisphere? 2 pi r square. If it is a total sphere, then it is 4 pi r square. A hemisphere is half, so 2 pi r square plus CSA, that is the curved surface area. The curved surface area is what? 2 pi r into that length. Okay, that length is, for example, height. The height is 9 here. So 2 pi r into h plus 2 pi r square. Agree? So 2 pi r square plus 2 pi r square. Can I write 4 pi r square plus 2 pi r into h? So I'm still not substituting the values. So first let's see whatever the common that we can get, right? So I can take 2 pi r common from this, right? 2 pi r, if I take common, here 2 is left, r is left, plus h is left, 2r plus h. So now substitute the values. So 2 into pi I will substitute as 22 by 7 into what was r? R is 5 by 2 means 2.5 into 2 into 2.5 plus what is h? H is 9, right? So if I solve this, I'll still keep like this. 2 into 22 by 7 into 2.5 into 2 into 2.5 is 5. 5 plus 9 is what? 14. So now you understood why I keep on uh, uh, keeping this value, right? 7, because this can be cut. 7 ones and 7 twos. So 2.5 into 2 is 5. So that means 2 into 22 into 2.5 into 2 is 5. So 2 into 5, 10. 10 into 22 is 220. So 220 what? Mm square. If it is a simple calculation, I'm doing it. If it is a complex, like we need to substitute, multiply, divide, so I'm leaving it. All right. So here, the surface area of this capsule, this medicine capsule is 220 mm square. Understood? See, when we initially look at the problem, we thought like it is, oh my God, how to do this, right? So if we can split that into three shapes, then we know this is a hemisphere, this is a cylinder, this is hemisphere. It is just that we need to know the values. If it is hemisphere, we need to know radius to find the surface area. So radius, the diameter is pi mm, that means the radius 2.5. So that we got it. Now for cylinder, what we need? Pi r square. So 2 pi r into h. H we need. What is h here? The total capsule length is 14. That means this radius of this hemisphere and that side hemisphere we need to subtract so that we'll get the height of the cylinder. So that is 9 mm. That's what we got. Then what is the surface area? Area of this side hemisphere plus curved surface area of the cylinder plus curved surface area or area of the hemisphere. So 2 pi r square, 2 pi r h, 2 pi r square. So if we add and substitute, so we got it is 220 mm square. So these kind of problems will be given in the board. Okay. So you need to think, apply the concepts, the formulas that we have learned, and then you can easily do that. Okay. It's not difficult. Okay, let's look at the next one. So I'll do three or four problems. So that way you will feel comfortable of applying your knowledge, what we have learned. Okay, so here, this is a even more complex problem. Okay, but just follow me. A tent is in the shape of a cylinder surmounted by a conical top. It is like an hut. Okay, so basically, let's draw the shape, right? So what is given is a tent is in the shape of a cone. Sorry, in the shape of a cylinder. Let's say this is the cylinder, the side view, right? And surmounted by a conical top. That means it's like that. You understood, right? So this is like a hut, a cylindrical hut. On the top, the roof is like this, cylindrical. Sorry, the conical. If the height and diameter of the cylindrical part are the height is given as 2.1 meters. So this is given, h is given. So the height of the cylindrical portion is 2.1 meter and the diameter is 4 meters. So that means this is given. This is 4 meters. That means here r equal to 2 meters. Understood? So the radius is 2 meters. The given data, you need to put that into a diagram. That getting into a diagram with the required height, radius, that is very important. Okay. And the slant height of the top, slant height means L. This is given from here to here. That equal to 2.8 meters, right? Find the area of the canvas used for making this tent. Also, find the cost of the canvas of the tent at a rate of 500 per meter square. Okay, here is also given a note. Note that the base of the tent will not be covered by the canvas. Base means this one. This is the base. So the base is not covered by the canvas. Yeah. So canvas we need for the cylindrical portion. That means the curved surface area plus the conical curved surface area. So that's where we need to fill with a canvas. You understood, right? So this is like a hut, a tent house. The tent house is in the cylindrical, at the cylindrical like walls. Walls are cylindrical and then the top is conical. So the cylindrical means the curved surface area of that cylindrical portion plus the curved surface area of the top. If we add those two, we will know how much canvas. Canvas means that cloth. How much cloth is required to cover this structure, right? So if we get the area of that canvas, then per meter square it is 500. Then we will know how much cost it is. So basically what we need is, so we need the area of tent. First we'll find the area of tent. That is nothing but the area of the canvas required. So the area of tent equal to uh, CSA of cylinder, right, plus CSA of cone, right? This is cylindrical plus this is cone. Now, what is the CSA of cylinder? Cylinder is 2 pi r into height h. So this is 2 pi r h plus what is CSA of cone? CSA is pi rl, right? The curved surface area is pi rl. Here we don't need total surface area because here we are not using the cloth. Cloth is using only on the curved side and also on the peripheral side. Only the curved surface area is enough. So now let's take pi r common. If I take pi r common, then it is 2h plus L. Okay, now substitute the values. Pi is, let's say 22 by 7 into what is R? R is how much? 2 meters. Into what is 2? 2h. 2 into what is h? 2.1 plus what is L? 2.8. So 2 into 2.1 is how much? For 4.2. 4.2 plus 2.8 is 5.7, right? So 22 by 7 into 2 into this total is 7. So this 7 gets cut. 22 into 2 is 44 meters square. So this is the area of tent. So this 44 meter nothing but area of canvas required. You agree? We need to cover this curved surface area with the canvas cloth. So the total area of canvas required is 44 meters square. And how much for each meter square? 500. Therefore, cost or total cost. Total cost of canvas equal to area of canvas. You're following me, right? Area of canvas into 500. So what is this area? 44 into 500. That means 0, 0 I can keep. 5 fours 20. 5 fours 20. So 22. So basically, how much you need? 22,000 rupees. You understood? So getting to the shape is important. So here the tent is in the cylindrical shape at the bottom and conical at the top. Then it is covered with a canvas cloth. So we found the total area of the curved surface area of the shape. That is 44 we got. If you multiply with that, how much per meter square, you'll get the total cost required to put canvas to this tent. Understood? Okay. Now, next one. A pen stand. A pen stand made of wood. Okay. So far what we covered, these two problems are surface areas. The curved surface area we took, right? Now we are moving into volumes. Okay. So here a pen stand made of wood. So this is the pen stand. If you see here in the diagram, this is a pen stand which is made of wood, is in the shape of a cuboid. Cuboid means our box, right? Our box that what we keep your pens, pencils, right? That box is in a shape of a cuboid because it has a length, it has a breadth, and it also has a height. Like our room, our classroom. It has both length. It's a 3D shape actually. It has a length, it has breadth, it has height. If all are equal, then it is a cube. If they are not equal, then it's a cuboid. So if you look at the shape here, it is like exactly our geometry box or something, right? It's a cuboid. And the dimensions are given. The dimensions are cuboid, right? So for a cuboid, the dimensions are length, breadth, and height, right? L is given, that is 15 centimeter. And the breadth is given, that is 10 centimeter. And the height is given, that is 3.5 centimeters. Okay. The radius, okay. A pen stand is made of wood in the shape of a cuboid with 4 conical depressions. You understood? So in that, if you look at the side view, in this, the holes you see here, right? The 4 holes, these are conical in shape so that you can fit our pen into that. You understood? Here, This each shape is a conical shape here. There are 4 cones here to hold the pens. So the dimension of the cuboid are given. The radius of each of the depressions. That means the radius of the cone is given. So let's say I am trying just one shape. This is where you keep the pen, right? That means this is like this, guys. Okay. So this is in the shape of a cone here, and so that you can exactly put the pen there. So here this radius is given. What is this radius? Is 0.5 centimeters. Okay. And the depth means this height is given. So h is 1.4 centimeters. The depth is given and radius is given of this conical shape. Find the volume of the wood in the entire stand. So if they just ask for the volume of the wood, I can just say L into B into H, length into breadth into height. I'll get the volume. But here what they are asking is, they have taken out these impressions, right, to keep the pen. That means that conical shape of the wood is taken out from that cuboid. So that means what I need to do is, I need to find the volume of one cone, multiply with 4, and then subtract this volume of conical impressions from this entire volume. You understand? So he's asking volume of the wood. So volume of, listen carefully, volume of wood equal to volume of what is that, volume of cuboid, right? What is the volume of cuboid? Length into breadth into h, minus 4 times volume of, what is that, conical impression, depressions actually, that's taken out, right? Now you understood what I'm trying to, how I'm trying to get to the area volume of the wood. The volume of the wood is the volume of the entire cuboid minus 4 times the volume of each conical depression that was cut out of that cuboid. So what is the volume of cuboid? L into B into H, minus 4 times of, what is volume of conical, what is volume of cone? We learn 1 by 3 pi r square H. So 1 by 3 pi r square H. So what is length and breadth and depth here? We know, right? 15 into 10 into 3.5. This is volume, minus 4 into 1 by 3 into, what is pi value? Let's say 22 by 7. What is R? R is 0.5. So 0.5 into 0.5 into what is height? 1.4. 7 ones, 7 twos or 0.2 because it is 1.4. Right? Now, with the 3, can I cut? I don't think. Right? So, yeah, this is a bit 15 into 35 this becomes. So 15 into 35, 10 into 3.5 minus zero point 0.5 0.5 into 0.5 is 5 5 is 25. So that becomes 0.25. 0.25 into 0.2. It's 0.25 into 0.2. So it is 50. And I need to put for 3 points. So 0.05. Is it? Yeah, 0.05. Because I'm multiplying with 0.2. Right? This is rough. So this is 0.05. This is 88. So 88 into 0.05 by 3. And that's all left. So if you simplify this, you will get the volume of the wood. Okay. So the units should be, what are the units here? Its volume should be in cubes because we are multiplying 3 times. Length, breadth, height. L into B into H. So it is cubic centimeter or centimeter cube. Okay. If you simplify that, you'll get the answer. Understood? So here, see this problem, if we read, initially we got an impression that how to find that volume, right? But if you understand and apply our knowledge, so it is basically two shapes. The problem is two shapes. One is cuboid, one is cone. So volume of cuboid we know, L into B into H. If it is a cube, A cube. If the side is A into A into A, it's a cuboid. In place of A into A into A, we'll substitute length into breadth into height. So LBH minus 4 times, because we have 4 depressions taken out which are conical. So 4 into volume of each. So 1 by 3 pi r square H. I just substituted the values. So if you simplify, you'll get the answer. And always remember to include the units. The units here are centimeter cube. Okay. Now let's get into the next one. As this is a difficult chapter, I am trying to cover all scenarios as much as possible. Okay, listen carefully. A solid consisting of a right circular cone. Okay, so there is a solid which consists of a right circular cone of height 120 centimeters and radius is 60 centimeters, standing on a hemisphere of radius 60 centimeter. Oh my God. Okay, so yeah, we need to give a lot of focus here. So the shape is in the form of a cone, okay, a solid consisting of a right circular cone. Let's say this is the cone. Of height is given. So the height is given. So which is h equal to how much? 120 centimeters. And the radius is given, or how much? 60 centimeters. Okay. So for cone, radius is given and height is given. Standing on a hemisphere of radius 60 centimeters. Okay, with the same, that means at the bottom, hold on, at the bottom, there is a hemisphere. There is a hemisphere at the bottom whose radius is also 60 centimeter, right? Because it is basically, it is like an ice cream, right? So you have a cone, on top of that, you put the cream, right? So like that, there is an hemisphere surrounded. It is standing on that hemisphere. That conical is, that cone shape is standing. Okay, centimeter is placed upright. Yeah, in a right circular cylinder full of water, such that it touches the bottom. Okay. Find the volume of water left in the cylinder if the radius of the cylinder is 60 centimeter. Okay, cylinder is also 60 centimeter and the height is 180. Okay, so basically this is solid. The conical with the hemisphere, it's standing, it's put into a cylinder. This is interesting problem, guys. So basically there is a cylinder of same, you understood? There is a cylinder of same diameter and this solid is kept into that cylinder. You understood? And here, let's say capital H, because I already used H for this one, right? This cone. So I'm using capital H here. That is the height of the cylinder. So that is given as 180 centimeters. And radius is same. So here, the radius is same for all the three shapes. Okay. For cone, for hemisphere, and for cylinder, the radius is same, which is 60 centimeter. So here basically two objects. One is a cylinder like a pipe, and in that cylinder, this solid is put into that. Now, find the volume of water left in the cylinder if the radius of the cylinder. Okay. So there is a cylinder where the water is filled, and now you put this object, this solid object into that cylinder. That means whatever the volume that this solid has, that amount of water would have spilled out. So how much volume is remaining? How much volume remaining means this total cylindrical volume minus the volume of this solid. Okay. So very simple. Volume of, see, if we understand the problem, if I draw this diagram, then I came to know, okay, the volume of the remaining water is the volume of the cylinder minus the volume of this solid. Volume of water remaining, right? the volume of water remaining is volume of cylinder minus volume of solid. But the volume, what is volume of solid? Yeah, I'll write from here to make use of the space. So volume of cylinder is what? Pi r square h. Here it is capital H minus what is the volume of solid? Volume of the solid is that solid has two shapes. So this is volume of cone. What is volume of cone? 1 by 3 pi r square h. Small h here. Small h is the height of the cone plus hemisphere 2 by 3 pi r cube. Right? So volume of the solid is volume of the volume of the cone plus volume of that hemisphere. The full sphere volume is 4 by 3 pi r cube. Hemisphere means 2 by 3 pi r cube. Now, from here, if I see, I can take pi r square common from all, right? If I take pi r square common, this becomes capital H minus, what is this? If I take pi r square, then this is small h by 3 plus, if I take pi r square, then this is 2 by 3 r. If I take pi r square and 1 by 3 also common, then this becomes 3h minus h minus 2r, right? This minus I am sending to both, and I took 3 common, so this should be multiplied with 3. Okay, so basically what this is, pi r square by 3 into 3h, 3h minus small h minus 2 times of radius. Let's find the values now. So yeah, this I'll keep as is, and then I'll substitute pi r square by 3 into, first find this value, 3 into h. What is h? 3 into 180, right? Minus, what is small h? 120 minus 2 into 60, right? So this is basically 3 into 180 is, yeah, let's use rough work. So 3 into 180 is 540 minus 120 and 120. So 240. That means 300. This value I will get as 300. So now substitute the values. 22 by 7 into r square is what? 60 into 60 by 3, pi r square by 3, right? Into this total value I simplified here, that is 300. So 3 ones, 3 hundreds. So nothing will go right. So this is 22 into 60 into 60 is 3600 into 100 by 7. So if you simplify, you will get the volume remaining, and the units are centimeter cube. Understood? So here, see, initially when we look at this problem, we thought like it is very difficult, because actually it is difficult, because here 3 shapes are given. A solid is given. Solid is a combination of cone and hemisphere, and then that solid is put into a cylinder which has filled with water. Now when you put this cylinder into the solid into that volume, whatever that volume of that solid, that amount of water will be spilled out. Then what is the remaining water, the volume of the remaining water they have asked. So how to do that? The volume of the remaining water is volume of the cylinder minus volume of the solid. The cylinder volume is pi r square h, and the volume of solid is the volume of the volume of the cone plus volume of hemisphere. So if you simplify that, this is how you'll get. So I suggest to take as much as common before you substitute the values. Otherwise, the calculations becomes very complex. Okay, if you start substituting the values here, it's become highly impossible for you to solve. Okay, so here if you do r cube pi value, right? So that's why try to take as much values as common, and then at the end, if you cannot further take the values common, at that time you substitute the values. That way the calculations become easy. So hope you guys understood. I think I have uh, one more last problem here, so let's do this. Okay, As I said before, this chapter is difficult, so I am trying to give as much as scenarios as possible with all the combination of shapes. The earlier problem, if you see, that's a combination of all the shapes that we learned: cone, cylinder, and sphere. Right. Let's see this. The last problem in this topic: a spherical glass vessel. Okay, there is a spherical glass vessel has a cylindrical neck. Okay, okay. There is a vessel which is spherical. Okay, so spherical means this is of this shape. It's a spherical vessel which has a neck that is cylindrical. You following me? So there is a glass which is spherical at the bottom and the top is cylindrical. Neck of 8 centimeter long and 2 centimeter diameter. So that means height is given. H of the cylinder is how much? 8 centimeter, and radius, let's say small r, is 2 centimeter. That is for the cylinder, this radius. Now this is the spherical, right? This I'll assume capital R, that the bottom is spherical, so that is capital R. And 2 centimeter in diameter. Okay, so this is diameter, small d I would say. Diameter is 2 centimeter. Okay, now the diameter of the spherical part, so capital D, the diameter of the spherical is 8.5 centimeters. See, you need to give more focus on what is given, radius or diameter. If it is diameter, while substituting, you have to find the radius by dividing that with 2. Okay, by measuring the amount of water it holds, a child finds the volume to be 345 centimeter cube. Okay, so someone has measured the volume and it is 345 centimeter is what they are saying. So we need to see whether that's correct or not. So how much volume this will hold? The volume of the sphere plus volume of the cylinder. Simple, right? So what we need to find, the amount of water. Yeah, volume of water, volume of water in spherical glass equal to volume of sphere plus volume of cylinder. You're following me, right? So for the best use of place, I'm starting from here. So what is volume of sphere? 4 by 3 pi capital R cube. Capital R I am using for the sphere and small r I am using for cylinder. When I have two values, I'll just indicate like that. So there is no confusion. And then volume of cylinder, pi small r square and h. You understood, right? So the volume of sphere is 4 pi r cube and this is pi r square h. So how much I can take common? I think I can take only pi as common. Nothing else I can take. So let's take pi as common. Then this becomes 4 by 3 r cube, capital R cube, plus small r square h. Okay, let's substitute the values. So 22 by 7 into 4 by 3 into what is capital R? Capital R is 8.5 by 2. That means, yeah, I can substitute like this, 8.5 by 2 whole cube or 4.25 you can do, right? Plus smaller is how much? 1 centimeter, right? This is 1 centimeter. So 1 square basically. So this is 1 square into h. H is how much? 8 centimeters. Okay. Yeah, I think this is a difficult I mean, the calculation is way difficult than we thought. So I think I'll leave it to you guys. So 4 by 3 into 8.5 cube by 2 cube means 8 plus 1 square into 8 is 8. So 4 ones, 4 twos we can do. I'll try to simplify as much as I can. And then I'll leave it to you guys. Yeah, 8.5 cube. It takes a lot of time. So 3 into 2 is 6 plus 8. Yeah, if you simplify that, you will get some value. That value, as I know, I have solved this before. So this value you will get something like 346 point something, right? But the child who has found that is 345, that is incorrect. Okay, so that much I can say. So you need to use your calculation skills to solve this. So basically, understanding the problem is key here. So a spherical glass vessel which is in cylindrical shape, sorry, which is the spherical glass vessel has a cylindrical neck. That means it is like a kuja, right? Where the bottom is in the spherical shape and the neck is in the cylindrical shape. So how much volume it can hold? How much volume it will hold? The volume of those two shapes, right? So you can fill water everywhere here, right? Up to the neck. You can fill the water here. That is the spherical volume. That is 4 by 3 pi r cube. And you can also fill the water in the neck, that cylindrical. So that is pi r square h. So I took pi common and substituted the values. So if I calculate, I'll get 346 point something centimeter cube, which is, but the child who has measured is 345, which is slightly incorrect. Okay, that much you can say. So with that, I think we are concluding this chapter. So in this chapter, the key things that we learned. So let me give a quick overview here, right? So in this chapter, we looked at the surface area for cone, cylinder, and sphere. So for cone, the curved surface area is pi rl. The total surface area is pi rl plus pi r square. And for cylinder, the curved surface area is 2 pi r into h. And the total surface area is 2 pi r h plus pi r square at the top, that circular shape, and pi r square at the bottom, right? And for sphere, the curved surface area and total surface area are same, that is 4 pi r square. If it is a hemisphere, which is means half of the sphere, that is 2 pi r square. And then we looked at the volume. The formulas for volume of a cone are 1 by 3 pi r square h. For cylinder, it is pi r square h. And for sphere, it is 4 by 3 pi r cube. And if it is a hemisphere, then it is 2 by 3 pi r cube. And then we looked at various problems. And I have covered all the combinations, right? All the combinations of the shapes. So here, the key is to just understand the problem and draw that into a picture and exactly identify the radius, height, length, all that stuff. So if you can get to that easily, then you can just apply our formulas like whatever we have learned, like curved surface area and volumes. So here in the volumes, you need to be little careful. In the volumes, it is like centimeter cubes, right? And also how much is left. That means you need to know which is the bigger shape minus the smaller shape you need to subtract. So when you take out that smaller shape volume from the bigger volume, then you will get the remaining volume. Okay, like that. So this is a classic example, this problem, right? It's a solid which has a cone and hemisphere that was put into a cylinder. See, all the shapes are covered here. So if you solve this problem, you can solve any problem in this surface areas and volumes. Okay, so that's what we looked at. So uh, hope you all understood this topic, and I will see you next time. If you have any doubts, please contact me using my Urban Pro profile. Okay. Thank you guys. Thanks for watching.